All right, so we're going to start actual lesson, or Unit 4 today. Unit 4 is going to be a quick hitter. If you notice, there's only six lessons. Couldn't think of the lesson word. 6 lessons in Unit 4, but we will have 2 quizzes, and we will have the test on the 18th, which is the week, the Thursday before our 2-week break. So that is a good time frame in that regards. Okay. All right.
Yeah.
So here we go. Let's start with 4.1. If you wouldn't mind doing the retrieval on page 2 of the packet that you should have picked up when you came in. Remember, when we're graphing lines, like we have to graph this line, we graph them with a straight edge. What are some alternatives to a ruler if you don't have a ruler? You could use your ID. Phone? No.
Phone case. Phone case without the phone in it.
Still no. You could use your homework packet. Yep, you could use your homework packet. You could use your ID. You could use your debit card or something like that. Or if you actually have a ruler, you could use a ruler. Okay, right? But we definitely want to be making our lines straight, and we want to be making them go all the way across. The arrowheads on the ends of your lines should be off the grid. Okay?
Okay.
So the arrowheads need to be on the ends of your lines, and those arrowheads need to be off of the grid of the graph. Okay? Go for it.
Oh wait,
Did you do some?
it's yes, right?
Yeah. It's no.
Yeah. Oh, do you have to like do the equation with -7?
Yeah.
Oh, see, I didn't do that. I just got -7 beats. I simplified the equation.
So this gives me a positive 5, so that's 0, 5 as my y-intercept. 1, 2, 3, 4, and 5. 2, 3, 4, and 5. Yeah. This gives me a -2 as my slope, which would be over 1. So that would be down 2, right 1. 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 Or I could go up 2 and left 1.
It's really easy.
What's really easy?
Wait, is this like what our unit is on?
No. It's just the start of our unit. We're going to get to putting multiple lines on there. Okay? So there is the line, the graph, if you will. Then it asked us if the point 1, 3 is or is not a solution. Well, the point 1, 3 is right 1 and up 3. This would be the point 1, 3 right there. It is on our line, yes. So yes, it is a solution. Another way of doing that is we could substitute 1 in for x and 3 in for y. So we'd get 3 equals -2 times 1 plus 5. And then we need to solve or simplify that until we get a true or a false equation. -2 times 1 is -2. -2 plus 5 is 3. 3 is equal to 3, so that is a true statement. That would be another way of proving that that point is on the line. Okay? Please, I've asked you once today already. Stay with us. One more. You don't need to be 4 pages ahead of us. Okay? Whoa, what happened there? What's up? Answered that question already today.
Oh, sorry.
You were probably busy talking with your neighbor. Okay. Indicate whether the given value is a solution to the equation. Show your work to justify your response. So the given value is n equals 5. So we're going to plug 5 in for n. So that would be negative 5 times 5 plus 13 has to equal negative 9. Negative 5 times 5 is negative 25. Negative 25 plus 13 is negative 12. Is negative 12 equal to negative 9? No. So then n is not a solution. If we plug in negative 7 in for b, then this would be 2 times negative 7 plus 5 equals 3 times negative 7 minus 2 plus 23. Negative 7 plus 5 is negative 2. Negative 7 minus 2 is negative 9. Negative, or 2 times negative 2 is negative 4. 3 times negative 9 is negative 27. Negative 27 plus 3 is negative 4. Negative 4 is equal to negative 4. So yes, negative 7 is the solution to that one. An alternative method to doing both of those problems is we could have just simply solved them for whatever value it is. So for instance, we could have gone negative 5n plus 13 equals negative 9. And I could have said, well, we need to subtract 13 from both sides. That makes this go away. That gives me negative 5n equals negative 22. Then I would have to divide by negative 5. That would give me n equals 22 fifths. So if 5 was 22 fifths, it would work, but it's not. So there's that one. Same thing in number 3. We could have solved that equation for b, and if we got negative 7, then it's a solution. Okay? Which we would have because of the truthness.
You can still do it like for 3, like with distributing, right?
Like distribute the 2 into these 2. Good? Love it. So today we're going to talk more about solving multi-step linear equations. Okay? So let's start here now on the jump start, which I believe is at the top of page 3. Okay? We want to evaluate the following expression for x equals 3. What does evaluate the following expression for x equals 3 mean to you? There's nothing to solve. There is no equal sign.
Simplify.
Let me rephrase my question. What are we going to do first? We're going to plug in 3 for x, right? And then we're going to simplify. Okay?
It also says review with the neighbor.
I know. Guess what? You have 2 other neighbors at your table.
But she doesn't have any.
Oh my gosh. It's not like I could be your neighbor or anything like that. Oh, that's right, I could. So if I plug in 3 for x, I get that, correct?
Yeah.
Okay?
Yeah.
What would you like to do first? Inside the parentheses first, right? Okay? Because that's please excuse my dear Aunt Sally. PEMDAS. Okay? So 2 times 3 is
6.
6. Okay? So then this would be 6 plus 3 is still inside the parentheses. 6 plus 3 is 9. We've exhausted everything inside the parentheses. Now what? 4 times 9 is 36. Then what? Add 36 plus 4 is? And lastly, 40 divided by 8 is 5. Compare with your neighbor then? Because we all should have got 5.
Yeah,
See?
see, I got
5,
five.
big one. Big 5.
I also put a big yes and then a yes.
Perfect. Yes, no, yes. What was the no? Oh, yes for the first one, yes. Yes. No for the middle one, yes for the last one. Correct. All right. So, let's talk about Elvira, the cafeteria manager, has just received a shipment of new trays, with the school logo prominently displayed in the middle of each tray. After unloading 4 cartons of trays in the pizza line, she realizes that students are arriving for lunch and she will have to wait until lunch is over before unloading the remaining cartons. The new trays are very popular, and in just a couple of minutes, 24 students have passed through the pizza line and are showing off the school logo on the trays. At this time, Elvira decides to divide the remaining trays in the pizza line into 3 equal groups, so she can also place some in the salad line and the sandwich line, hoping to attract students to the other lines. After doing so, she realizes that each of the 3 serving lines has 12 new trays. Okay? Then she says, that's not many trays for each line. I wonder how many trays there were in each of the cartons that she unloaded. Okay? So what are we looking for here?
How many trays? We're in the full carton.
How many trays were in the full carton? So what can we call that?
The unknown.
Okay, so what do we call unknowns in math?
X.
Variables, or so any letter, you want to choose X?
Actually, like T.
T for trays? Okay, that's fine. So here's crucial thing. For all of these problems, okay, especially when they're word problems, you should really define T is equal to the number of trays in each carton. Right?
Yeah.
Is that what you said? Yep, carton. In a word problem, we gotta define what we're looking for. Okay? So, in the end, we know how many trays were left in each line, correct?
Yeah.
How many?
12.
12. So that means it's going to equal 12 somewhere at the end. Let's go down here. Oh, I guess I can't get it in there. Let me make a white box. Yes, sure. There. And then we fill it. Oh, that's not helping. That one's got to go away. So in the end, it's equal to 12, correct?
Yeah.
Okay. All right, let's work backwards. She realizes that, so she divided each of the remaining trays into 3 equal groups, right? So that means over on this side, we're going to have a dividing by 3, correct? Okay. Working backwards, 24 students already took a tray, right?
Yeah.
So is that going to be an add or a subtract from our total? Subtract, because they already took them, right? So somewhere on top, we're going to have a minus 24. How many cartons did she unload? 4 of them, right? And each carton had T trays in it, so that means she started with 4 T trays.
I see. Wow, that's good.
Right?
Yeah.
Okay, so now let's read through the problem again to make sure our equation makes sense. After unloading 4 cartons of trays in the pizza line, that's the 4T part, she realizes that students are arriving for lunch and she'll have to wait. New trays are very popular, and in just a couple minutes, 24 students have passed through. So that would be 4T minus 4. That's how many trays are left in her original stack. She divided it into 3 parts, and there's 12 in each one. Yes? Okay, so that works out for me. All right, let's solve this equation now. Let's figure out how many were in each carton. What would be the first thing that you would do to solve that equation? Multiply both sides by 3 because we want to get rid of that fraction, right? Okay, I like it. So I'm going to multiply the left side by 3, and we'll multiply the right side by 3. The left side multiplying by 3 cancels out the denominator of the 3. So what's left over? Left side. 4T minus 24 is left over. Right side, if I multiply the right side by 3, what do we get? 36? Okay. What would be next? Add 24 to each side. That adding of the 24 cancels that out right there. So then what's left on the left side? 4T. And what's on the right side now?
60.
60?
Yeah.
Okay. What's next?
Divided by 4.
Divided by 4. So that cancels out that multiplying by 4. So what's left on the left side? T. What's the right side?
15.
15. Oops, that's a bad 1-5. But because it's a word problem, 15 trays.
Do we have to do it like this and like make an equation like that?
You will have to at some point in time, yeah. Not every single time, but
Okay.
yes.
Do we have to create a story problem?
Out of the equation?
Yeah.
Potentially.
But that won't be on our unit test.
You never know.
Oh,
Okay?
No way.
Way.
Okay, then can I just use this problem?
I don't know.
But with like, some
dollars.
Yeah. I'm gonna write you a whole
You give out
A
dollars.
whole essay. That's awesome. Okay. So here are 3 different equations. Let's solve them. Okay? I'm not worried necessarily about the order of things. There was, back over here, there were, underneath all this work that we just did, they had the order of what some things happened, and then they just had another, like, make another equation type of a thing. So let's forget about that. Let's just solve these equations, solve these different ones. Okay? So the first one. Actually, no, we just did one like the first one. Let's skip that one. Let's go to the middle one. Now, what would you do first in the middle one? Can I do anything inside the parentheses?
You divide by 2.
What do you mean? Divide both sides by 2? Do we agree? Can we divide both sides by 2? As long as we do the same thing on both sides, we can do it mathematically, right? Okay? So you're saying, Allie, is to divide both sides by 2?
Yeah.
Okay? So then that makes those 2's go away. And what's left over on the left side?
X over 3 plus 4.
Do I need the parentheses around it? No. Okay. And what's on the right side? 6. Okay. What will we do next? Subtract 4 from both sides? That makes this 4 go away. And what do I have left on the left side? X over 3. What do I have on the right side? 2. Okay. Now what would we do? Multiply by 3. That makes the denominator go away. What's left over on the left side? X. What's left on the right side? Okay. You now individually do the first one and the third one. Okay? Go for it. First step in the first one. Multiply by 3. What do we get when we multiply by 3? Left side we get 2 times the quantity, x plus 4. Right side we get 36. Okay. Then what? We could distribute. Okay. Or we could divide by 2, either one, right? Okay, doesn't matter. If I distribute, then I get 2x plus 8 equals 36. Then what? Subtract 8. That gives me 28. Okay. Then? And that gives us 14.
Or different nation. I don't know what that was.
She did do a couple of different exercises there. Okay. Good to go on that one? Again, a reminder. What am I checking on this stuff? Work. Yeah. You got to show work on this stuff. Yeah.
I do.
First step down here. Multiply by 3 again. Gives me 2x plus 4 equals 36. Then
Minus 4 on both sides.
that gives me
2x equals 32.
then
Divide by 2 on both sides.
that gives me
X equals 16.
huh? Questions on either one of those? Jackson, put your homework away. Now, on the next page, there's some filling in of things that you need to do or need to fill in on. Okay? So here is the fillings ins that you need to fill in.